Good morning. On behalf of Engineers Australia, I'm delighted to welcome you all to today's webinar, Engineering the Future, Harnessing Connected Data. My name is Amanda and I'll be your host for today. Firstly, in keeping with our custom, Engineers Australia acknowledges the traditional custodians of the country throughout Australia and recognises their continuing connection to land, waters and community. We pay our respects to them, their cultures, to elders past and present. Before we get started, I'd like to acknowledge that today's webinar is being hosted with Engineers Australia's industry partner, Autodesk. For over 4 decades, Autodesk have worked together with their customers to transform how things are made, and in doing so, they have also transformed what can be made. Today, Autodesk solutions span countless industries, empowering innovators everywhere. But they are restless to do more and don't believe in waiting for progress, they believe in making it. By combining and recombining technologies, by blurring boundaries, reinventing rules, and merging fields, by unleashing talent and unlocking insights across industries, and by helping their customers converge on solutions to the challenges we all face today. Today, we will hear from 2 speakers, followed by a live audience Q&A, and I encourage you to send questions through to our speakers via the YouTube chat box. I'd now like to welcome our first speaker, Eddie Kriegel, Senior Manager, AECO Data Strategy. As part of Autodesk Data Industry Strategy team, Eddie focuses on BIM and technology workflows, supporting a data at the centre approach for architects, engineers, contractors, and owner-operators. Eddie has over 20 years of experience in the architecture offices on a range of projects from single-family residential to office, federal, civic, and aviation. Please welcome Eddie Kriegel.
Thank you for that introduction. I'm Eddie Kriegel. I'm with Autodesk's AECO Data Strategy team, and I'm here to talk about reshaping the AECO industry through data. Autodesk has been involved in planning, design, construction, operations, the full project lifecycle with all of our tools. We support a number of different industries: building, transportation, water, and industrial. If you've ever seen an Autodesk presentation before, you've likely seen a slide very similar to this. I think where this slide is a little unique and our approach to data becomes a little unique is most of the time after this slide, we begin talking about how our tools impact one of these industries specifically. In this presentation around data, while we're going to focus on the building industry primarily, Autodesk is committed to supporting all industry types around data. Data is really a platform neutral or market neutral approach. We have challenges with data as an industry. We create more data now than we ever have before. And in fact, 95% of that data goes unused. Anybody in the room who has done an architectural project or a civil engineering project has probably created a file and called it final, and then created another one called final, and probably even another one, final, and then you placed it in a folder called final, and you stashed it somewhere where you would hopefully remember that you had that data. When we all do that across a project lifecycle, trying to make sure that we have the information that we need at the time that we need it, we end up with a lot of copy data, multipliable data, and all of that information causes a lot of inefficiency and a lot of rework. In fact, this is a $1.8 trillion problem, this cost of duplicate, bad, or unreliable data in our industry. There's 1.8 trillion annually. On top of that, not only are we creating more content than we ever have before, but we are using more applications to create that content than we ever have before. Roughly 75% of us in the AEC industry use 6 or more applications every day to do the job that we need to do. That is not only Revit or Civil 3D, that's also tools like browsers, Microsoft Word, PowerPoint. It takes a lot of different applications for us to even just be the engineers, the architects, or the contractors that we are. To solve this problem, Autodesk is furthering our journey into a digital transformation. So we're all familiar with analog to CAD. I personally started my career hand drafting on a drafting board, moved directly into AutoCAD within my first year in practice. BIM came onto the market in the early 2000s, and right now we're in that connected BIM world. We're in an environment where we work connected to the internet almost 24/7. We can work from anywhere, anytime. All of our files are accessed digitally. We save documents up to the cloud. We collaborate across offices and across different geos or different countries, much in the same way that I'm presenting to you from Denver, Colorado today. We could also be collaborating on an architectural project or a civil engineering project. But what we are working on and what data is going to be the foundation for is the next generation. What is that future of BIM? What we believe is that the future will be an outcome-based approach, where we're using data to begin to define what outcomes we want in our buildings, on our roads, and our facilities going forward. So in a very similar way to how BIM first was when it came on the market, we would have BIM for 3D, or BIM for 4D, or BIM for cost estimating, or BIM for asset management. That data underlayer is going to pin outcomes, but those outcomes are going to be daylight analysis, a sustainability target or goal. Driving those different outcomes are going to help create that data-rich platform, which will eventually help us be powered by AI. And that AI isn't going to replicate the human condition or our design or engineering processes, but augment. So how do we iterate faster? How do we iterate more frequently? How do we make sure that we're analyzing and selecting the best possible outcomes for our projects? You can see how data has grown across our industry. I'm going to give you an example over some projects over a 100-year span in Kansas City. Kansas City, Missouri, it is it's in the Midwest of the United States. It's where I started my architectural practice, and I've actually worked on a number of these projects. So in 1931, the Kansas City Art Museum was built. That project was drawn by hand, ink on linen sheets. It was 23 sheets in the architectural set. So it took 23 building sheets to document the entire facility, all 350,000 square feet, which gave us roughly 15,000 square feet per sheet. A couple of years later, in 1933, the Kansas City Power and Light building was built. The project was 46 sheets in the document set, so double just in a 2-year time. Jump forward to 1988, One Kansas City Place was designed and constructed, 81 sheets in the drawing set. This was one of the first projects that was drafted in CAD in the region at the time. Also the tallest building in a 3-state area. 2003, the IRS Processing Center, 300 sheets in the drawing set, 1.1 million square feet. This was one of the first projects done in Revit right after Autodesk acquired them, and the largest project done in Revit at the time. It was also one of the first projects where the outcomes in the project expanded beyond just getting the building complete. This was a project where clash detection was used, which was an emerging technology at the time. And you'll see as we expand the outcomes that we want in these projects, the amount of documentation and the amount of information in our drawing set continues to expand. Not only that, but the systems within the building continue to become more complex. So in 2010, the NNSA processing facility, 1.5 million square feet. This was a manufacturing facility for the federal government. One of the outcomes that they wanted was a fully ready asset model. Revit at the time couldn't handle the amount of data that was required, so all of the information was stored in a Microsoft Access database. And even then, while we had less information in the model than we do today, even back 15 years ago in this project, that information wasn't very valid. As part of the program for this building, one of the requirements was a 16-foot diameter water tank. That information was pulled out of the Microsoft Access database and fed into the Revit model. 16 square foot diameter plus the space to get around it. A water tank of that size is very heavy, so it was a reinforced concrete floor. As we got the project complete and we began moving equipment into the facility, we realized that that 16-foot tank was a typo. It was actually a 16-inch diameter water tank. Bad data leads to bad outcomes, which leads to project overruns. And then finally, in 2023, the Kansas City Airport was completed, 1.1 million square feet as well. Over 20,000 sheets in the document set. It's a massive amount of information. One of the most interesting things about all of these projects that you see on the screen, while the amount of information continues to compound on itself, all of these projects were completed in roughly the same amount of time. So the amount of time it took to design and build a project documented in 23 sheets back in 1931 is roughly equal to the amount of information it took to design and build the airport project in 2023. We're creating more information and using more teams, more different services inside the building components. We need better ways to manage that information going forward. At the same time, all of that bad information not only means more time and more coordination, but bad information has a cost. The state of Texas recently completed an 11-year study and found that roughly 31% of the change orders on their projects were due to errors and omissions. Basically, 31% of the change orders were due to bad information in their document sets. So how do we not only make the information more accurate, more reliable, but also reduce the amount of errors that we have in our document sets? A third of the change orders leading to errors is definitely a target we can reduce. And then just one last point about the cost of bad data. Google in June of this year released an update to its Gemini AI platform. So basically anything you can Google in the Google platform. And if you open your smartphone and you Google, how many small rocks should I eat every day? Google will actually advise you, based on quotes from geologists, to eat one small rock every day. Now, we don't recommend eating a rock every day. We don't recommend eating a rock at all. But imagine if this was the architectural or design engineering industry, and we told you you didn't need fire exits, or you didn't need sprinklers, or you didn't need any other component that drove health and life safety. The outcomes would be horrible. We need to make sure that when we are using AI, or when we're trying to do any kind of automation, that we're also validating the outcomes and we're validating the data outputs that we receive because they have real world impacts. What we want to do is we want to provide good information as a foundation, and then build automation, build AI, build those features on top of it. And all of that data is still trapped in all of those applications that we have used 6 or more times every day. So if I want to get to that data, if I want to then validate the quality of that information, I have to be an expert at Revit, at Civil 3D, at Microsoft Excel, at PowerPoint, or whatever tool has the information in it. What we are focused on in the data strategy team is really trying to not only solve the data quality piece, but also that data accessibility piece. We want to break those file silos down and create data that is more accessible. We want to take that unreliability and add trust in the data. And we want to be able to connect that data to a variety of other sources so it can be accessible in a variety of locations based on your role on the project, who you are, and what outcomes you're trying to drive. So what is our vision for better data? We see data as the responsibility of everybody on the project team. We want to make that data more connected so that we have access to it for better decision-making, for improved operational efficiency, for better resource allocation. We need to make that data trusted which means we need standardization, we need better methods for quality control, and we need to make that data accessible either through a centralized common data environment at CDE. However, we need to be able to control access so we still have the right security, and we need to be able to report that data to all the project stakeholders. But what's important to all of us really depends on which phase we are in the project and who we are and what outcomes we're trying to drive. For instance, designers and engineers might need that data visualized or validated for design-based decisions. Contractors are going to look to federate and aggregate that information so they begin to do takeoffs and estimates and scheduling. And the owner needs that data to be structured and standardized in a relevant way, because they're not only going to be doing this one project, they're going to be doing tens or possibly hundreds of projects across their campus, and data consistency across all of those projects is going to be critical. In this way, we can all begin to work towards a more cohesive data strategy for the projects. How we're going to do that is in our CDE, and that's the Autodesk Construction Cloud. We're not going to create a new location. We're not going to make another version of the Construction Cloud or of Autodesk Docs to store data in. We're building on top of an existing platform to try to improve data continuity and data value. So we are beginning to expand that Docs environment. We're looking to create that information and begin to make data more granular. So as we begin to bridge data between different authoring platforms like Revit, Civil 3D, Navisworks, you will begin to see that data become more granularized. What does that really mean? So what is granular data and how do we access it? Granular data is being able to access the information within a file, so within a Word doc, within an Excel file, within a Revit model, within a Civil 3D model, and be able to pull that information out without having to get into the authoring tool itself. So I can access information within as an example, a BIM model, manipulate that information, and be able to update the model or update the contents based on my role on the project without actually having to open the authoring platform. That's what we mean when we talk about making data more granular. And that is our goal as part of a data strategy, being able to connect those bits of information into a more complete and cohesive data model. So that will start with access by all of the various project team members. We are expanding the different personality types or different stakeholder types who can access that information, and then to granularize that data over time, right? So breaking down those files and being able to have that information accessible as point solutions in the cloud. We're also expanding our availability for data itself. We've expanded even at a raw file level, your ability to host and access files. We started with the North America Data Center. We expanded a couple of years ago to Ireland and Australia. And as of July the 1st, we've expanded our data centers even further by adding 5 more. We now support Canada, Germany, India, Japan, and the UK. So simply by bringing data closer to you physically, it reduces latency, improves speed, which improves the entire user experience. It allows you to have better trust in the information that you have in the cloud and drive higher accuracy. So what is this granular data experience going to be like? Now that the information is closer to you, you have there's a data center in Australia, or if you're working in other regions of the world, there's possibly one in country or one in a country much closer. That allows more speed and more access to data. But as we continue to create more granular outcomes, what you're going to experience today will feel more like a series of point solutions. There are tools like Content Catalog or Datum 360 that will begin to plug into some of these experiences and bridge between tools. Content Catalog is a great example of what that bridge feels like. It is a tool that's both accessible in Revit. You can add families into Revit through the content catalog and be able to manage a content library across your project or across your organization. You can share those libraries across multiple projects or share them to other organizations. But you could also access all that same information from a web browser via the Autodesk Construction Cloud. As we continue to create more granular and more connected services, we're doing that through APIs, through in-product experiences, and through a series of online services like Content Catalog, where it's not quite a product, definitely not in the desktop sense. All of those are going to become more seamless in the future state. So as an example, what does granular data look like? How would you access it today? This is a screenshot of Revit. You can see the blue areas there. Those are native properties in Revit. They've always been there. They're going to continue to be there. And in a lot of ways, the experience of being in Revit won't really change. You're still going to author walls and doors and floors and add data components and parameters to them as you need to. We currently have a tool called the Parameter Service, where you can begin to add custom properties that is accessible via the model coordination tool inside of ACC. So those properties can be added into the Revit model themselves through the web interface, again, kind of breaking down those barriers of what your touch points are and where you can actually author information. We're working to extend that farther by allowing you to actually manipulate those properties. You can see that kind of represented in that green area at the bottom, where data can now be driven through a web interface or through other tooling, and it will show up in the Revit model in the authoring platform itself. Now, none of that data in this last case is going to be stored in there. It'll all be stored in the AEC data model. Storing data in Revit is really kind of a poor idea. It tends not to work very well. It bloats the model. It makes it very inefficient. But it doesn't mean that data can't be accessible. So our future state is being able to store that data and the data that we need in the AEC data model and have it accessible in the authoring platform, very similar to the graphic you're seeing on the screen. So what this will look like over time is that you will have that foundational layer of Autodesk Docs in the AEC data model. All of the files and the granular data that you store there will be saved into the data model. So that's Plant 3D, Civil 3D, Revit. And then different access points beyond the authoring tools will be things like APIs, like the AEC data model APIs, or in-product experience like the Parameter Services tool or Model Analytics, or different connected clients like the Data Exchange tool. This will allow a variety of different stakeholders different ways to get to the same information. So what does that look like, and what is your experience today? Just to give you some examples of what this could be, I just recently spoke about the Data Exchange tool. Think about data exchanges as taking parts of models and being able to share them to other project stakeholders in a low trust environment. So I can take a portion of a Revit model or a Civil 3D model or a Rhino model, be able to capture a collection of the components in that model and the data that goes with them, and be able to share them to another application. However, when I share them, that information can't be manipulated or changed, but it can be appended. So in this example, we have a Revit model of two buildings that are connected. We're going to take a portion of that Revit model, and we're going to share it to our glazing designer who's going to put a glass roof over that courtyard. We're selecting some of the content to be able to share, and we're creating a data exchange file out of that and hosting that into ACC. That can then be pulled into Rhino in this case, where that file can then be brought in. I have all the data points that I need. I have all of the elements in that file that I need, and I can append that with the roof structure and any contact points within that roof structure I need to bring it back to the building structure or attach to the roof line or anything else. I can then import that roof element back into my existing Revit model, visualize all of that in a complete and total package. And not only can all of this be combined but because it is all data rich, I can also report on it. So I can connect this directly to a tool like Power BI, do takeoffs, do visualizations, and understand how all of these components kind of work together, or any of the data that's associated to them. Not only that, but the data exchange is actually a bit of granular data. And the user experience will be to actually see that as a file, and it'll look like a file within ACC. It'll have its own file type and its own little icon, but it'll work just like any other file that you would have hosted in the cloud. You can share it to somebody else. You can use the ACC Bridge tool to bridge it between different projects. As you update that file, it will continue to version and update itself. You can roll back to a previous version. It will act like a file, even though the data is only a subset of a piece of data in another file. The data exchange tool hosts a number of different formats. You can see what some of these are on the screen. Even things as simple as Revit. You no longer everyone doesn't have to work in the same version of Revit. If you have somebody working in 2024 and somebody else working in 2026, not everybody has to upgrade. You can use the data exchange tool to share data back and forth. It supports IFC. We support Rhino, as you had just saw in the video, Civil 3D. Really, the goal here is to remove the reliance on everyone having to learn a new authoring platform and being able to share data between different project stakeholders. And again, in that low trust environment, you can trust that it won't be edited. You can trust that it won't be manipulated, but they will have all the information that they need to do the job that they need to do. Content catalog I spoke about earlier. So this is really a library that users can create and store firm-specific or project-specific content online, and then simply drag and drop it into Revit or drag and drop it into Civil 3D. One of the benefits about this library is you can now create firm-specific content, be able to store it in a centralized location, and even subdivide this into a variety of different content types. There can be one for healthcare. Maybe you have a library just for hospitals, and then your airport team has a library just for aviation work. Your Civil 3D team has a library for roads and highways, but maybe the bridge team has their own as well. So it allows not only a central location for that content, but team members who are using those libraries can get updates. So when the content is updated online, that content can be pushed to various projects, and the team members can be alerted that there's a new piece of content. In this way, it helps firms and organizations meet their internal standards or project standards on projects where they work repeatedly. And then finally, all of this as a good data foundation makes things like this possible, right? Where you can actually go into a model and do a natural language query. Now, this isn't available in Autodesk tools today, but this was done by a partner who was exploring different ways to be able to connect and relate to a model, again, outside of an authoring platform. So here we can actually just ask, show me the windows on the second floor, or show me all of the windows that have a certain profile to them. Show me all the doors with a fire rating. In this case, we're looking at ductwork and we're looking at electrical systems, right? We can begin to actually analyze the model based on content types and some of the data components that are within it using simple natural language. Again, not available today, but these are the kind of tools that we're working to bring you very near in the future. Autodesk is working really hard to provide a robust data platform and continuity across a variety of different project types. As I stated at the very beginning of this presentation, we really see data as an agnostic source. It is universal across all projects and across all markets. We are looking to do some very large-scale things with data in the very near future. Thank you for your time.
Thank you, Eddie, for your input. I'd now like to welcome our second speaker, Seamus Murphy, Technical Director at Aurecon. Seamus is a principal at Aurecon, a chartered engineer specialising in the development and planning of new rail infrastructure projects across major infrastructure developments. With extensive experience in complex transportation solutions, recently contributed to key Sydney Metro Southwest projects, including Central Station and the Bankstown Line conversion to Metro. His expertise encompasses the technical and strategic challenges of integrating complex systems, bringing proven capabilities in project planning, stakeholder coordination, and the delivery of critical infrastructure that serves communities and supports economic growth. Please welcome Seamus Murphy.
Okay, thank you for the introduction. And look, thank you for the opportunity to share with you today. So look, my share is on the role of engineers and my view on the future with data. Look, I'm also going to touch on some of the things Aurecon is doing with data, in particular around the rail planning space. So today I wanted to talk through a bit of a fundamental shift, that's happening in engineering, how we're moving from simply collecting data to make it truly intelligent and actionable. So look, a fundamental shift in engineering. Look, we're at a turning point in engineering. For too long, we've focused on data collection and generation, but now we need to move just beyond data gathering and creation. The real opportunity lies in making data work for us, turning it into strategic real-time decisions, that drive outcomes for the communities we serve. So look, data rich, but insight poor. The reality is we're drowning in data. Data capture is increasing exponentially. And the challenge is around data skills. These skills remain scarce in our engineering teams. This gap between data generation and data literacy, it's really holding us back. So look, the stakes couldn't be higher. We're under pressure to deliver more with less. The construction industry has essentially been flat, making AC industries one of the lowest performing major industries across markets. I believe getting the value from data is a key way to close this productivity gap and transform how we design and deliver infrastructure. So I wanted to touch on things that are holding us back. What's preventing this transformation? And the skills gap is clearly key. Few engineers are trained in data science, including AI and machine learning. The trust gap, tools such as AI are still seen as a black box. And there's an integration gap. We've got legacy systems, siloed data, firewalls, security. And there's a change gap. We are risk adverse and slow cultural adoption. So what I was going to do was walk through and share 3 case studies with you that we're currently doing in Aurecon with our data and with our key clients. So I was keen to touch on some of our learnings too and share. So my first case study focuses on understanding human behavior to optimize railway station design. So look, traditionally we design station based on physical counting, calculations, standards, guidelines. Now in this example, we partnered with a data broker and we used mobile phone data to map actual passenger flows at stations. This revealed movement patterns that we hadn't expected. Where people were actually congregating, how they were navigating spaces, how they interacted between different transport modes, be it train to bus or cycle movements. So look, these type of insights were not typically captured in our traditional methods, and it was fast. You know, we could use heat maps to quickly see pinch points and problem areas. Now, some of the learnings for us were really around the opportunities. We realized that we could, you know, layer in even more data, demographics, for example, build personas around the user. So not just understand how people move, but who they are and what are their needs. And this also raised sort of important questions, you know, to what standard should govern this type of data use? How do we balance these insights with privacy? Or what standard are we measuring the results upon? But look, the key learning here was that data doesn't improve our designs. It really fundamentally changes how we think about human-centered outcomes. So the second case study I wanted to share was around a problem every engineering firm faces. So this is around decades of drawings and reports and knowledge trapped in cloud or hard storage. So we've all accumulated decades of engineering assets, but they are essentially unstructured data, searchable only if you really understand exactly what you're looking for. So Aurecon has a strategic partnership with Nomic around accelerating the way we build on our AI searchable knowledge bases. So what this has led to, suddenly our engineers, say working on a bridge, can instantly access similar designs from our history, complete with lessons learned, performance data, and a station designer could see how platform layouts had evolved and what works best. So this becomes a sort of rapid prototyping tool. So instead of starting from scratch, teams could build off knowledge and do it at speed. Now, the learnings for us here, I mean, look at significant around, you know, there's a low barrier to entry. This type of solution is everywhere, and most businesses are on their own journey. It's a really simple and effective first step. And look, the second learning was around enterprise systems and the criticality. You know, this can't be a standalone tool with no engagement with underlying data. And look, what excited me most about this was really seeing such wide reach across our business. And this, you know, talks to that easy wins. So the third case study represents perhaps the biggest shift from reactive to predictive maintenance. And we've heard about this before, and the value if we get it right. So this particular client that we worked with, we took 10 years of sort of asset libraries, condition data, maintenance records, failure patterns, and we applied machine learning to identify and prioritize interventions. So again, we used heat maps to quickly aid and where to target. And some of the learnings from this particular project was that the journey wasn't smooth. Data quality from legacy systems was one of our biggest challenges. And that's around years of consistent data entry, you know, fragmented systems, varying standards, all had to be cleaned, normalized. And, you know, again, start with the easy wins. Don't try to solve everything at once. Pick assets with the cleanest data, you know, the most obvious patterns. But in saying that, you've got to ensure that the value is being brought forward. So look, the success here depends importantly on change management, just as much as the technical capability. So, and what I mean by that is, maintenance crews needed to trust predictions. The operator needed to understand the recommendations. And this change management, it's business change, it's cultural change, and this is hard work. And look, but when it works, the impact is transformational. So look, these are some of some case studies to sort of show that fundamental shift that's underway that I mentioned at the start. And the last decade was no doubt about collecting and generating data. This decade ahead needs to be about making data intelligent and bringing value from how we engineer the future. So we need to move from asking what happened to what should we do next. So system conductors. This transformation is already underway. We are now drawing down on value from our data stores within our own businesses and the partnerships that we build with our clients. AI will help us do the heavy lifting, without a doubt. AI will also handle more routine design tasks to support us lifting the bar more broadly. And engineers, as they become system conductors, we will continue to integrate complex systems with human needs. And we need to continue to make those critical decisions that require judgment and creativity. We will become effectively data-driven leaders, who can see patterns across systems and understand human impact on our decisions. And we will leverage data, AI, really to create better infrastructure for the communities that use them. So thank you, and look forward to what's ahead and any questions that you may have. Thank you.
Hi, it's now your turn to get involved. Please ask our speakers questions via the chat box and who your question is directed to. Thank you to everyone who submitted questions whilst registering also. I'd now like to welcome Brett Casson from Autodesk, who is Director, APAC and EMEA AECO Strategy. Brett is an experienced leader driving strategic initiatives in the architecture, engineering and construction sectors across the Asia Pacific, Europe and Middle Eastern regions. He specialises in public sector collaboration, digital transformation and platform services, and is dedicated to advancing innovation in the AEC. Please welcome Brett, who will now open the Q&A. Thanks, Brett.
Yes, thanks, Amanda, and thanks to our two speakers. Thanks to Eddie and Seamus. We do have a few questions that I think we should pick up on, but before we do that, I'd like to ask both our presenters just one question each. I'd like to start with Eddie. And Eddie, I think what you presented is so interesting, particularly from the lens of a technology provider and where we're going and what we're doing. What I think it plays into is to I guess, expand on that opportunity from a customer perspective. What do they need to do to start so that they can take advantage of all this great technology coming through? What does a data strategy look like? How would where does a customer begin?
I think that's a great question. It is one that we get regularly. I think any good data strategy, any good data foundation starts with trying to identify outcomes. What outcomes are you as an organization or you as a project trying to create, trying to drive? Is that design analysis? Is that efficiency? Is it sustainability? Understanding the outcomes you want to drive is the first step. Aligning those outcomes with the right data to explore some of the tools like the AEC data model APIs or the data exchanges that we talked about. Explore those tools that really help drive those outcomes. And then I would say, if you don't, obviously this was a really short presentation. We didn't get to cover everything that we would have ideally liked to have been able to show. There are a lot more tools out there. Explore the tools and the options. And then there is a lot more to come and a lot richer announcements that we have in the next 3 to 4 weeks during Autodesk University. So I would say check that out. It's always an inspiring event, and it helps people kind of gather some talking points for direction forward.
So I think the message is start, begin, and yesterday was the best day, but today is just as good. So let's start on that data journey. My next question is to Seamus, and I think Seamus, so interesting to see what Aurecon's doing and what you're doing specifically around the analytics piece. And my question to you is, it feels like engineering as a profession is evolving and changing. And my question to you is, where does engineering, like traditional engineering, start? And what you're talking about, or where Aurecon's going, where does that begin? Is the line a little bit blurred, is what I would say now?
I think so. Yeah, look, I don't know the answer, but on that, but would say that what I observe, what I see in our young people is some right steps. I mean, we're seeing a lot more people with, dual degree in data analytics, or other sort of supplementing engineering with other skill sets, be it through biomedicine or robotics. So I think that's really encouraging, right? And I think it's going to help us shape what we need to do in the future ahead. And I think we're seeing really good things come from the new generation of engineers in this space. I think there's a long way to go, and I suspect I suspect we're going to shape the future is going to shape quite differently. But look, I think that's a really exciting thing to think about.
Thank you for that. I might start with a couple of questions that have come in on registration. The first one being to you, Eddie, from Angus in Victoria, asking you, are there any examples of data validation processes when AI value is correct, not in format only, but matching the other records, drawings, manual specs, etc.? Eddie, thank you.
Yeah, that is a great question. It is also something that I think is currently a work in progress. There is, I can't think of a good example of an AI tool that will actually review specs and drawings and compare your specs to your drawings. However, what you will find in Autodesk's Construction Cloud is a tool called the Autodesk Assistant. And you can actually begin to use that tool. It's either released now or be released very soon, to actually query what is in the drawings and ask the drawings questions about content that it will find in your drawing set. Look for that tool to continue to grow and build, and we will develop that further for deeper queries across the drawing. So in an eventual use case, you'd be able to actually look at the manuals, the specs, and the drawings and cross compare.
Thank you for that. Brett, we've had a question that came in from John Paulo, who is watching in Victoria, asking you, what skills should students focus on developing now to be ready for an engineering career shaped by connected data? Thanks, Brett.
Yeah, I think it's another great question. I really liked what Seamus said before around having different skills, probably non-traditional, what we regard as traditional engineering skills. Things like data analytics. From an Autodesk perspective, we have a chief data scientist and we have a chief scientist that works for Autodesk. And, whilst from a technology perspective, you would think that that's table stakes and we should have that. and you should expect that from us. What we're actually observing from the engineering community is that those skills or those roles are now appearing across what we regard as traditional engineering, traditional sort of structural, bridge, civil, anything to do with architecture, engineering, and construction. So I think there's no right or wrong answer there. I think what's happening is that the skills are becoming interchangeable, and non-traditional engineering skills are being highly valued, particularly around data analytics. So think of all the STEM fields, which are very traditional fields, but branching out into analytics. And I think what Seamus presented for some of the work that Aurecon are doing, particularly at the front end of projects and maybe looking at lessons learned, is really around data analytics. In AECO, we have very specific data sets depending on where we sit in terms of design or construction or operations. And those skills are definitely interchangeable across the entire life cycle or the entire profession. So I think engineering obviously is a core skill, but branching out into other areas that are probably non-traditional, I think is really important, and it is very, very highly valued today.
Thank you, Brett. And just staying with you for now, a question that's coming from Zar asking you, Brett, how can engineering organisations leverage connected data across design, construction and operations to not only improve efficiency and reduce costs, but also create more sustainable and resilient infrastructure in the future? Thanks for that question, Zar.
Yeah, and again, a great question. Historically, what used to happen for projects in the built environment is that I think the engineering specifics are very, very well defined. The way in which a bridge is delivered, or a road, or a building, very, very specifics. I think what didn't happen historically are those information requirements. What do we need to effectively design, build, and operate this asset? And so I think in terms of leveraging data, there needs to be very prescriptive requirements that come from both the client and the value chain or supply chain that can deliver on those very specific requirements. And it needs to be a conversation with the client in the room to say, these are the things that we can deliver, and then the client needs to say, these are the things that we actually need. And we have standards around this, and we can apply those standards. It all comes back to, again, being very prescriptive around the data that's required, BIM execution plans, level of information need, anything that's contained in, I think, ISO 19650, which is a great place to start, because that is a clearly defined standard, and that's a standard that's very specific to information requirements. So the downstream effects of having prescriptive data across the life cycle are twofold. One is that you can effectively manage that asset in a much more efficient way. You know more about that asset. You know how it was created, how it was designed, how it was constructed. And secondary to that, you get the added benefits of things like being more sustainable and resilient. We know from the onset of the design of this asset or this built environment what the embodied carbon will be, and thus what the operational carbon will be. So I think then that leads into a conversation about how we can design more resilient infrastructure. We have to be prescriptive around what we want or what we can deliver from a client and a consultant and a contractor perspective. And once we do that, we're going to see all of these added benefits.
Thanks, Brett. Eddie, we've had a great question that's come in from Brett. Brett's watching in Victoria, asking you, will this connected data enhance my company's desire for more streamlined work, sharing with resources based in other countries? Eddie.
That is a great question. One of the things everybody strives for with the idea of connected data, and especially with some of the AI agents, is this level of efficiency. I do think that if that is the outcome that you are trying to drive to, getting to that outcome is probably some low-hanging fruit. We've seen a number of examples of that just in recent customer visits. For one example, there was a customer who had a series of Dynamo scripts, and they had a very robust Dynamo library. They replaced the Dynamo library with a private agentic AI, and that AI agent wrote Dynamo scripts on their behalf and cut 80% out of the time it took them to manage the library, update the scripts, police the scripts, all of those things. So I do think that those are, it's a very achievable goal, and it's a very real goal. And the best place to start is the things that take the most of your time today.
Thanks for that, Eddie. Brett, a question from Anthony, watching in South Australia. Good afternoon to you, asking, how can you ensure the flow of data from one party to another, example, designer to builder to asset owner, is efficient whilst maintaining clear responsibilities? Brett.
Another great question. The biggest challenge that we see on projects is not so much the technology being able to deliver interoperability. And I'm not suggesting that that's perfect, and there's not one perfect model for that. But the biggest challenge we see is lack of being prescriptive about what data is exchanged and how we exchange it on a project, and the level of information need or the level of information required at any point in time. And so this comes back to what I was saying before, which is we have to define both how we're going to do this and the responsibilities of each of the parties at the start of a project. It's once the contracts have been awarded and design has started, and the contractor is on board, and they're digging holes in the ground, it's just too late. And it's very, very hard, or very, very difficult, almost impossible retrospectively to go back and say, well, hang on, here's how we want to exchange information. And the other thing I would say is, if we have these clear responsibilities, we have clear ownership of the data as well, because at the end of the project, we want to be very clear around who is the custodian, or who is going to be the custodian of this very, very valuable piece of information today for this asset and the built environment. So my answer to Anthony is, up front, we have to be very clear on the type of data that we're exchanging, when we exchange it, and how much we exchange. And that played into what Eddie showed with some of the things that we're working on, which is we only want to share what's required. We don't need to share the entire data set. And we're moving into that world. And I think that's a better place to land. And so interoperability, will always be, I think, challenging, but we're trying to overcome that. But if we don't define it up front, we're going to have problems, and we're never going to get to where we need to.
Thanks for that, Brett. We've just probably time for one more question that's come in to you, Eddie, asking, in terms of your concept of granularizing the data from various authoring platforms, to what degree do you think the authoring software industry as a whole is on board? Eddie.
I think you would actually be surprised by the number of other software companies who feel that granular data is something we all need to strive for. Everything that you saw Autodesk present today around things like the data exchange, all of those happened because we have agreements with all of those other companies, with Tekla, with Power BI, with Microsoft in that case, with Rhino, around data interoperability and data exchange. I think being able to easily move information back and forth between different platforms only actually helps everyone, because you can spend your time in the tool and in the authoring platform that best drives the outcome that you want to drive, but that might not be the only tool that you want to use throughout the entire project process. So being able to more seamlessly move between tools, I think, opens up a lot more independence to use the tool that you want in the workflow that you need. I think you'll find a lot of them are behind the idea.
Thank you, thank you. And the Q&A has gone very quickly today, and thank you for all your questions, and apologies if we didn't get round to yours. But it is all the time we have, so please join me once again in thanking Eddie Kriegel, Seamus Murphy and Brett Casson for their time and input. I'd also like to warmly thank Engineers Australia's long-standing industry partner, Autodesk, for their support. As always, please take a couple of minutes to complete a short feedback form, which is linked in the description box. Helps us to improve and plan future sessions. Thank you again for joining us, and I look forward to seeing you at our next Industry Partners event. Thank you and good afternoon.